Welcome, and today we're going to talk about backend abstractions. And with backend abstractions, I mean the building blocks that enable us to build backends web services. And I don't only want to show the theoretical grounding of this, but in a case study of Node.js and Express, I want to show how these abstractions are actually implemented and how you can concretely build web services within Node.js and Express. And as a last point, I also want to show some more general programming abstractions that are commonly used in those backends that can hopefully help you also with implementing the assignment. What I want you to take away with today is an overview of the important concepts and abstractions that are inherent in developing applications in the backend. I want you to understand that there's a difference between those concepts and abstractions and their concrete executions. Namely, that if you understand the higher level concepts, that you can implement them in any programming language, right? And while I want you to also get the ability to map these concepts to the counterparts in Node.js and Express, I also want you to understand that you can easily apply them also to any other programming language and framework that implements those abstractions. So let's do a very quick recap from last week. What is a web server? So if you remember, the web server was both physical and logical. And if you want to sum it up, it's a program that is running on the computer / server, mostly in the data center, that accepts HTTP requests over a specific port and answers with responses. And we also looked at a very basic web server in Node.js. So Node.js has the ability to open sockets where people can send requests to, and then you can respond with this response header. So if you look at this example, that's a very bare bones basic web server that you can write in Node. And in this case, you're listening on port 8080, and for any request that comes in, you just write back the header 200 for OK, and you send out a message, hello world. That's it. And if you remember from last week, when we looked at CGI, you can use, if you use another web server like Apache, for instance, you can use any scripting language or any programming language on the server to output the HTTP response headers and response body in order for to initiate the request response cycle. But if you actually want to build applications on the web, there's more to it, right? On the basic bare bones, it's request comes in, do something on the server, request goes out. But if you want to efficiently build web applications on the back end, we have to ask ourselves, what are the building blocks for that? And I want to show you what those building blocks are, but I also want to show you how they actually look like in an implemented programming language. So we're going to do a case study later on. Not necessarily a case study, but I'm just going to show you examples of how that looks like in Node and Express. And in Node, you've already gotten to know it's a JavaScript runtime that runs on the server, basically, doesn't run on the browser, meaning that not all the APIs that you know from the browser are going to be available because it's a runtime. It doesn't include all the libraries that you would have as APIs in the browser. It is, as JavaScript is in the browser, Node.js is also event-driven. Specifically, in your case, they're going to listen for requests, and you going to have callbacks for those requests. And what it also does is it facilitates synchronous and asynchronous computation. I don't want to say more about it because I don't think that the programming language that we're using should be a focus in the lecture. I think the programming language that we're using is a vehicle for teaching and a vehicle for understanding these concepts. And so I'm not going to say more about Node. That Node in itself is very interesting in the way that the request model works, and in the way that the threading works, and so on and so forth. However, given that we only have 3 ETS in web engineering, I feel like time is better spent not focusing on the language, but focusing on the more high-level concepts. Within Node, we have this thing called npm that you may have heard before. It manages dependencies, similar to Maven, for instance, in Java. And then Express.js is a framework that is built for Node.js. So it has the utilities and implements the abstractions that we're going to talk about. And so I want to split this up into two categories. I want to have the web abstractions on top here, which take more space, and I want to have the general purpose abstractions that commonly come within those backends as sort of just mentioning them in passing. Those are things that you hopefully already know from other courses. However, I just want to mention them for you to know. So as always, we're going to start with an HTTP request. That is the main concept we're working with, and the other main concept is the HTTP response. Right, that we already know. We know what HTTP is. We've worked extensively with those things. Now within the requests, there is something called a route, and the route is an abstraction that does URL mapping. The route in itself maybe is not on the same abstraction levels as the other things that you will see here. It's more of a concept that if you take your URL and respond to it, that is a route you're establishing. And you can establish that by looking at the request method: get, post, put, delete, and so on. You can establish a route by looking at the path parameters. So hopefully you read the pre-reading on REST. If you haven't read it, you can still very easily follow along here. I think it's more I think it is more important. Wait, 1 second, sorry. I think it's more important for you to understand, because you're not building your own REST API here. However, I want to say that there's a lot of misinformation on REST out there. Everyone calls everything that has something to do with HTTP REST, which is not entirely true. So the way you design those endpoints for your API, REST is one way of doing it. And this very short and I would say interesting book with like maybe 30 pages or so will prepare you for understanding what APIs out there, and hopefully also designing your own. And path parameters are the parameters that are within the URL path that you will see, but we will see an example later on. Then we have query parameters that we've seen. For instance, you remember the Met API we had, has image was a query parameter, or Q was a query parameter. No, what's going on? Yeah, there you go. Oops. Of course. There you go. Then we have the message body. The message body is the payload that comes with post requests, for instance, or any other request. So in the message body, you can say, I want to send data over HTTP to a server. And then to a lesser extent, we're not going to talk about that too much today. We have the content negotiation header, also called the accept header, where we say for the same resource, we want to have HTML or we want to have JSON, or so on and so forth. So that is also something that we can distinguish in the request, and is an important abstraction. Now in the responses, we all know the status code. It is important for us to know. Probably the most important thing with the status code is the dynamic content of the response that comes with the HTTP response. So you do something on the server, there's some manipulation going on, you're getting data, you have some business logic, and then in the end you have to return some dynamic content. With that content comes a content type. So oftentimes those servers are pretty good, and they can infer what's going on. They know that what you're saving here is an object, so it's got JSON, or they see that you're trying to put out HTML, so they're going to put HTML on that. But you can also explicitly set, or you should explicitly set the content type. Then we have some abstraction on caching behavior. We have some abstractions on encoding. Encoding is kind of a misleading word here. It's about a compression, but it's called encoding in the HTTP response headers. And also static files are part of that. So if you just want to map a folder to be wrapped with the HTTP response, that's also, I think, an important concept to kind of remember. And somewhere in between request and response, we have this thing that has been established because HTTP itself is stateless, but we don't want it to be stateless. So we have cookies and sessions that establish sort of a connection, a stateful connection between request and response. And then not inherently a concept from the web itself or from HTTP, but it's something that facilitates all those things. It's called a middleware. And the middleware is code that manipulates those requests and response objects. We're going to go into what middleware is in a couple of slides. Now, on the general purpose front, there's something that is kind of in between those two, namely content templating. So templating is a technique that enables separation of concerns, where you have some behavior that you want to program and you want to send out a response or HTTP responses. But you want to separate the presentation from the response, which can be HTML, which can be JSON, for instance, from the actual manipulation of the data that you need. Then we have environment variables. So environment variables enable you to inject configuration in different stages of the deployment pipeline, and in general allow you to have secrets within your source code and data conversion. So with secrets, I mean things like API keys or maybe URLs that you don't want to expose publicly on GitHub, for instance. So those things will usually go in environment variables or other ways of dealing with those secrets, like configuration files that you don't version. And now you have standard utilities, things like networking, file system, the database, and then there's also something to be said about design and architecture. So or I call it code organization because we're not at the architecture stage yet, I would say. So in Node, for instance, I'm going to talk about modularization. Layered architecture is something you probably have heard of before, of how you can organize your code and deal with certain abstractions. And maybe some of you have also heard of model view controller, which is a very commonly used abstraction in web backends. However, I feel like it's a bit overused for a lot of things. So in this case, I'm not going to talk much about model view controller because I think it's just a special case of a layered architecture that is more important to understand than the model view controller in concretely. All right. So based on this kind of vast overview of what the abstractions are, I now want to go through sort of step by step through most of these and show how those work out in Node.js and Express. So before we move on, are there any questions so far? Let me see if there are any hands up. No hands up yet, and no questions so far. So now I have the questions paying more on my side. So if you do have questions in between, just pop them in there. Okay. So with that, okay. And so I wanted to also add a quick add in here. So if you want to know more about these design and architecture types of things that are more general purpose than the web, potentially next year I will teach a course on software design and architecture. So just follow, the space and TIS, and I will probably say more about that at the end of the semester also. Okay, so a very basic thing, what we have is routes. So that's the entry point for us. If someone comes in with a request, we have these things called routes that map the request to certain functionality or logic in our code. And what you see here, so this is the full program. If you copy paste this in a JavaScript file and you run Node on it, this will already run a server. And if you go to, in this case, localhost and port 3000, and then with a path hello, it will send back hello world to you. So what you need for that is you need this dependency and module called Express. You say require Express, and you instantiate Express by saying the app equals Express. Just that's the function that is coming back. And based on that, with app, you get the ability to create routes. So if you say app.get, right? Go further here. If you say app.get, you get the ability to say react to the request method get when it comes in on the path hello, right? And what we will give you is these abstractions called request and response, which are currently HTTP request and response objects. And then in the response, I can fill up the response object. In this case, I say, well, send this content. And this is the dynamic content or response I was talking about earlier. So this is the most basic endpoint you can do, and that's already your route. And okay, so almost forgot to mention it. The default status of any of those routes. So if you don't specify any status in the response, then it will be 200. It's going to be okay. There's a question by Gary. Is Express like a constructor for the API? So you can think of it that way. Yeah. So Express is this larger framework, and we're going to go in a little bit. We're going to go into how modules work in Node, and then you will understand why you can do, just parentheses, open and close, and construct this object based on that. Okay. Now let's have a look at how the request and response objects actually work. So here we have another example of a request method. In this case, we have a put method, and this is an example of changing an existing recipe. Okay, so what you have here is those REST path parameters that I talked about earlier. So if you have a route that says recipes, in the route you can now sort of establish variables. So if you say colon and then a name, this will be a variable that you can use in the body with the requests object. You can say request or RUQ the params.id. If the variable were called identifier, you can say .identifier, right? So this is how you establish this. And then you can also access query parameters. You can say request.query.hasImage in this case, right? So if hasImage is a query parameter that you pass after the question mark in your URL, you can get it this way. Now the status code that I'm sending here. So if you look at the code, what we're doing is we're getting a recipe ID, we're getting hasImage as a query parameter, and then we're going through some service API and saying, well, find me this recipe ID with hasImage. If you don't find the recipe ID, well, then send back 404. Now there are two ways to set the headers, the response headers for status in Express. So the one, every time you just say res for the response, and you can either say status and then continue with what you're doing and construct the object even more. However, if you're already done with what you're doing and you just want to send back 404, you just send status. And here we have the request body. So in this case, this is put. So input, in the path parameters, we put the ID that we want to change, and in the payload, in the request body, in the message body, we put the objects that we want to change. There's a question. What is Express in general? A REST API? It's not a REST API. So Express is a web framework. So it's a set of libraries that implement the abstractions that I talked about earlier. So it's not exposed over HTTP. It's just a set. It's libraries that you can access in memory by calling them. Okay, so in this case, you have the message body here, and you say, well, the message body, I will also add this update method from the recipe, and here I can then send back a JSON. And in this case, it will understand that this is an object, and that you will send it back as a JSON. So you don't have to set the content type, but you could, right? Okay, and I want to quickly interject as to why this whole thing with the message body works. Because if you remember HTTP is a textual protocol. So if you inspect the HTTP request and response headers, you can see what's going on there. And there's no inherent structure in there. So the reason why we can just say request.body and the body then is a structured key value object is because of these middlewares. And what middleware functions do is they can manipulate the request and response objects in every request response cycle. And there are multiple of those. So with an Express, you can have, and you almost always will have multiple middlewares that interject things that you do. So if you look at the example here, what they do here is with app.use, you can inject this middleware, and they use the express JSON middleware and the express URL encoded middleware. And what this enables is, or what will happen is, before the request object and response object come to you in the route, it will go through these middleware objects. The middleware object will do something to it. So in this case, the JSON, express JSON middleware will look at the message body. It will determine, it will determine that the body is JSON, and it will parse it for you. And then we'll say, well, we're gonna add a structural feature here, which is gonna be called requested body, and that's why you can access this. If, say, you have your own interesting weird protocol that you want to implement within the message body, you can also write your own middleware. Okay. But the next thing that is an important topic, and has been around for many times that we talk about in this lecture, are cookies. So cookies, as I said before, are sort of the consequence of HTTP being stateless, but as a client-server application, we still want to have some state. We want to establish some notion of associating requests to the same entity, the same person, the same device, and so on and so forth. Now, cookies are an abstraction that can be set both by the client and the server in the HTTP headers. And then what happens is, once you set the cookie, it's going to be transmitted on every request and response cycle. In every request and response header, you will have those cookies. Thus, cookies shouldn't be too long, right? And now sessions are a special case of information that use cookies. And what you do is you generate a unique identifier, and you store only that unique identifier within the cookie. So every time there's a back and forth in request and response, the only information you have here is the 16 or 32 bytes session ID, or whatever longer, but it's not going to be kilobytes, right? It's not going to be the full information. So the information you want to store about the entity that you want to have this state with is not exposed to everyone, because everyone can look at cookies. If you go into the browser, you can look exactly what cookies store about you. And the way that this works in Express and Node.js is, in the request object, you have this cookies list, an object where you can access existing items in the cookie. And again, and just want to kind of prime you to that only works because there's a middleware that does this for you. So the middleware in this case looks at the request, it looks at the request header and says, there's a cookie here, and this cookie has this key value pair sort of structure. So what we'll do is we'll parse this key value structure and make it available as an object. Now, if you want to set a cookie, you say response.cookie. That's just a set method where you provide the name of the and then the value, and then this is written into the response header. And then the next time you have a turnaround, this will also come into the request header. Now, environment variables or configurations are tricky. So environment variables or any sort of secret management is very common in general, so it doesn't have to necessarily have anything to do with the web itself. Those environment variables provide you a very standard way of exposing configurable values within your program. And also, the environment variables itself enable another level of indirection between separating configuration from code. Now, what do you think is worthy of an environment variable? It's in the title here: secrets, things that you don't like to be exposed in your code base. Things like passwords, things like API keys, things like sort of secret URLs, things that can be security critical. And a lot of people do this wrong, because if there are loads of studies out there and loads of scrapers that scrape API keys for all sorts of things. And sometimes it happens by accident. Sometimes people don't know better. I really urge you to before you commit something, don't have any secret information within your code base that you're committing to a public repository or even private repository for the matter. Who knows? Now, the way you can inject those things, you can pass it as parameters. You can say, well, I have a parameter, in this case, through process.argv, similar to what you may be seen in the C programming language or Java also. You have a list of parameters to the node process, and you can pass information there. However, I would say a better way of doing this is if the parameters come from the environment that the operating system provides. And what environment variables enable for you to do is to have different values for certain things on different stages of the application. So maybe in development, you're testing against some specific server. Then you put the URL of that server in the environment variable. Now, when you're going into staging environments or production environments, you can change this environment variable. And this flexibility in configuration is what's important here. So if you want to access environment variables in Node, you say process.env, and this will give you the environment variables by the operating system. Now, in Unix systems, you can set environment variables by saying export, then up in uppercase, environment variable equals and the value. In Windows, I'm pretty sure it's similar. It's not the exact same thing. Just bear in mind that if you do this in the console, so if you have a console open, your terminal, and you just do it there, then as soon as you close the terminal window, it's going to be gone. So if you want to permanently add environment variables in Unix systems, there's something called bashrc or bash profile. Put it in there. In Windows, I'm afraid you have to look it up. If I remember correctly, there is an environment variable register. So there's some graphical interface where you can add environment variables, and then those are available on the whole system. All right. And for A3, just a quick word, in A3, there are a few environment variables you have to set. And if you run the tests, then those tests will set their own environment variables. Okay, so something that we're not really using for A3, but it's still an important abstraction is templating. So a lot of the times you want to have a separation between the program logic and the way that things present themselves. And this is where template engines come in. What they do is they provide you a way of specifying the output. Sometimes it's HTML with you know, variables inside and control structures. Sometimes it's a bit of a different language that then transpiles to HTML or JSON or whatever have you, right? There are all sorts of different template engines. I don't have an overview. You know, there are hundreds of them. I'm going to show you one here, and you know, this one is a pretty standard one for Express. There are many other ones if you prefer other ones. I myself prefer the ones where I can write actual HTML. But just to give you an example, again, it's a middleware, right? So this is a middleware concept where we set the view engine to be the pugs. This is what it's called. I think at some point it was called Jade. And what happens is you get access to request and the response object, and you do something in between that indicates what template you want, and then this middleware will facilitate the replacement of variables. Now, if you look at the route here, the method that facilitates this templating is called render. So in render, the first parameter is the template. So this is the template. So if I say users here, then it will go to my template folder basically, and we'll get the users.pog template. And this is what it looks like. It's just a stripped down version of HTML. Not a big fan of it, but wanted to show you that these also exist. Where if you write equals and then this in this case title and heading, for instance, it will replace these with the variables that you pass as a second parameter. So as a second parameter, you pass an object where the key is a variable name and the value is what you want to replace with it. Now, this can be simple literals, strings and numbers, for instance. This can be also complex objects. So if you pass a complex object, in a lot of those template engines and template languages, you have control structures, in this case, a for loop, where you can loop over these structures. So if we combine this template with the code we see at the top left here, what we'll get is this output for the render response. Okay, so it will take the template, it will take the data that we pass to the template and replace it over and over until we get the render response. Now, so we're not going to go through templating in A3, as I said. However, templating is in the recent, I would say, let's say 5 to 7 years, with front-end frameworks like React and Angular and Vue coming out and becoming more popular, and single-page applications becoming more mainstream and more popular. Templating has become a very important concept also for front ends. So we'll look at templating again in A4 and also in the lectures on front-end abstractions. Now, just a quick overview, just so you know that it exists. There's standard libraries. Okay, there's Alexander had a question. Can you also insert a script with this kind of templating? Do you mean this in a vulnerability kind of way? So it depends on the template. Oops, sorry, I just wanted to go back. It depends on the templating engine. So it really depends on what kind of control structures and controls in general you have in place within the template language engine. Okay. Yeah. Okay. So to make it more concrete. So yes. So usually, if a lot of template engines will just take the value that you have within your passing in the code and will output it into the template. So if someone passes a value that's a script, and then the script does something, that's definitely an injection attack that might happen. So again, as I mentioned a couple weeks ago in the JavaScript vulnerability injection example, sanitize your inputs and make sure that nothing's going on. Some of the template engines will do that for you. Not all of them though. So I would be vigilant here, and for every input that you can trust, I would sanitize them. And sanitizing in many cases just means escaping. But sanitization depends really on the input that you have. Ashavir has a question. Is template rendering done on server side or client side? So the template rendering that I'm showing you here, this is done server side. So if you look at the route here, here's the routes get / meaning that someone came into the root of the web server, and then the web server renders that and sends back. So render does this, it generates this HTML here. It generates this HTML here and sends it back as an HTTP response. So the rendering here is happening on the server. But yeah, in the, I think 2 weeks or so, we're going to talk about front-end abstractions on how front-end frameworks like Vue.js that we're looking at can do templating also on the client. Oops, man. There's a question by Michael. Is it mandatory that functions passed to routes are async? Yes, I think so. Do they have to be async? Maybe not. Let me get back to you on that. I'm not entirely sure. It would make sense since it wouldn't matter. I would say if you do it async, then it's easier for you to just use await structures within the routes and the responses of the routes, right? If you don't have the async before that, well, it's a callback anyway. It's already an asynchronous computation, so it doesn't matter, right? So I'm not sure if you have to. Probably don't have to, but it doesn't matter. Okay, so moving on to HTTP. Here, I just want to say that a lot of programming languages give you the ability to work with HTTP. However, if we look at this JavaScript dilemma here, we have JavaScript from the front end, we have JavaScript from the back end with Node. Now, most people think, well, everything I can do on the front end, I can do on the back end. However, while the language is the same, the standard libraries and, or let's say the common libraries that you use and the APIs that you're used to on the front end might not be available on the back end or work a bit differently. That's the case, for instance, for modules. So Node.js is not entirely ES6. And there's some weirdness with ES6 modules. However, they have a similar modularization strategy that in a few seconds. In case of networking, someone built a framework called Node.fetch that has the exact same contract and functionality as the one you know from the front end. So here you can use the exact same thing. So here an example, you can use it's promise based. You can use await. It's the exact same API and contract. So I think that's very nice because we're familiar with this, right? And makes it easier for us to build on top of that. Now, persistent storage, specifically files, is also part of the standard utilities. And this is an example in the A3 template. We already gave this to you. Yeah, so there is an API that lets you interact with the underlying file system. The nice thing about Node is that it has both synchronous and asynchronous operations, so that I think it really depends on your use case. Sometimes you want to directly read something and give it back. Sometimes it makes sense to have an asynchronous operations. For instance, you work with large files and you want to have different sorts of callbacks for them. Node gives you the ability to do both of those things. I want to caution you about one thing, in particular when it comes to the file system in combination with or persistent storage in general, in combination with deploying on cloud systems. So if you remember from last week, I very briefly talked about things like platform as a service as a cloud offering. What platform as a service is, it gives you an interface where you can deploy your applications to. Oftentimes based on your Git repository, it will detect, oh, this is a Node application, or you will tell them how to start the process, and then it will run. What you need to understand about these systems is that they're ephemeral, meaning that the server that this is run on when you deploy it the first time might not be the server that it's run on when you access it an hour ago, an hour later, a day later, and so on and so forth. Meaning that those platforms as a service or any sort of cloud offering, I would say, have the ability to just tear down certain resources if they don't need them anymore, or they're misbehaving, or they want to place them somewhere else, and spin them up somewhere else. Meaning that if you write on a local file system, and this is also true for local databases, by the way. If you have a local database that stores their files on the local file system, and you are deploying on those cloud systems, it might happen, and it does happen, that the files that you're writing will not be there anymore the next time the instance is spinned up somewhere else. So just keep them in mind that if you want to write to persistent storage, let's say files, or let's say to a database or to an events store or whatever, you have to use so-called backend services. So those are external services that are deployed somewhere else, that where it doesn't matter that if you tear down this instance and bring it back up again, you still have the connection to your persistent storage, right? And there's an interesting article here on 12-factor. 12-factor in general is a bit of a best practice approach when deploying applications on the web. So I think it's an interesting read for any of you. And before I go into modules, I particularly didn't mention databases because, quite frankly, I think you've dealt a lot with databases. If you quickly Google Node.js Express and any database you like, you will find code on how to access those databases. You will find abstractions on how to deal with them. I don't think it's worth our time here in web engineering to go into that in detail. And that's why also, if you look at A3, a lot of the things that you need to do is in memory. And if I say in memory, you shouldn't overthink this. In memory is not some special thing that you need to do. In memory just means create a global variable, and that's fine, right? Create a variable that is encapsulated within a module, for instance, right? And that's already in memory storage, because your Node.js process is going to be up and running, and when requests come in, they're going to be able to access the variable. So for A3 specifically, don't overthink how to store the data, just have them in internal memory, and that's fine. Now let's move on to modules, which again, I want to emphasize are not the same as the ES6 modules. So many times when I implemented the A3 yesterday, I didn't write require, I wrote, I think it is import, right? And it just works a bit differently. So if you look at this example here, right? Number one, you can use the relative path. just pointing this out there. So if, for instance, you're in routes artworks and you want to import this util met.js, you can just use relative paths to get there. Now, the second thing is that what you can use here, if I say require, what met will become is just the elements that are in exports. So if you are in a file, oh yeah, so the modules in JavaScript in general, but in Node.js in particular, are file-based. So you have to create your own file to have a module. Now, if you want to make this file a module, you have to have this thing called module.exports. And what exports is an object. And everything that is in that object will be part of the variable that you're assigning it here. So if you look at the left side and you say met equals require, what this require will do is it will return the contents of the module exports you see on the right side. So in this case, in the module exports, I'm just exposing the search function. So I have a search function that is asynchronous, has a parameter term and max as an optional parameter. And what I'll do is I have this object exports that will just set search. Now, going back to the question from before, how they work with Express, you can also say module.export equals a function. And then when you require that module, you can just call this as a function, right? And very standard way here. Everything in the module file that is not within this module exports is considered private, right? And this is how you can deal with encapsulation and implementation details and so on and so forth. It also means that, for instance, if you want to have a session store, right, you can build a modules for sessions, and then the in-memory data structure is just a map or an object within the module. And the way that you deal with the access to that in-memory data structure is by expose methods. Now we're almost coming to an end, and I want to just say quickly one thing. This is not necessarily web engineering, but in general, you want to consider how you want to organize your architecture. So module, are one thing, and you've probably already all heard about this. Layered architecture, in this case, if you look at it from top to bottom, we already worked with the first tier. We worked with user interfaces where we rendered things in the browser. We used JavaScript for that. Then the presentations. So if you look at the associated concepts here, if there's a presentation layer, you want to have templates maybe of organizing and separating these things out. If you are on the application layer, you might want to have routes, and you want to organize those routes maybe in different files. So specific routes can be in different files, and in A3 you see an example of that. That, for instance, the route for artworks is a different file, and the routes for what is it, checkout, I think, or card is a different file, and so on and so forth. And if you have a domain model that has captures logic and so on and so forth, well, then you might want to use modules, and you can organize them in folders and files. And I just wanted to quickly say that. And the thing is that the principle here is that one layer doesn't necessarily need to know. So the top layer doesn't, the bottom layer doesn't need to know about the top layer. So the domain model can be used by others, doesn't need to know what kind of application models they're part of it. Same with the presentation, that there's some logic going on that I'm dealing within the application model, and the presentation layer doesn't really need to know about that. It's kind of separating concerns out a little bit and makes it easier to collaborate, makes it easier to work with larger code bases. So I hope when you're implementing A3, for instance, it's not going to be one huge file. However, what I want to say is I wouldn't also over-engineer. So you don't need to have tons of classes and modules. It's not necessary. So with that, I kind of want to close this lecture. And I want to, oh, damn, that was not my intention, but let's do it until the end anyway. Yes, I have two more. Yes, so if we look at all these abstractions that I told you about at the beginning, and and we looked at how those are implemented in Node.js, and maybe think to other programming languages that you have used for the web. So last week, someone talked about Java and Spring, for instance. There's Ruby on Rails, there's Python with Django, and so on and so forth. So my question here to you is, do the libraries and APIs that are provided in other language adhere to this view? What are the differences you see? Do you think this is a good model of thinking about it? And I think the other interesting thought that came to my mind is this view future-proof? So we're dealing, so a lot of the abstractions here are based on the protocols, which seem pretty stable. The question is, are they future-proof? And if they are, think about why they're future-proof. And if you think they're not, then it would be great to discuss why you think they're not future-proof. Now we can either discuss this now if anyone has thoughts, or we can maybe leave it to the beginning of next week where you can reflect on, maybe other views that you've seen. And maybe also for next week in the beginning, I might just quickly go through some of the frameworks I used. I used a lot of Ruby on Rails. I used Sinatra with Ruby. I used Django. I've used Spring before. So maybe I'll quickly go through those things and see what the counterpart is there. And maybe we can see the limitations of this abstraction view that I presented to you. But let me see if there are any questions. If not, then I want to close with that. And hopefully see you next week.